So in this video we are going to discuss the graphs related to photoelectric effect. So in the last video we were discussing about, or that part was discussing what is photoelectric effect, and whatever we have said in words or like statements, that is pictorially given as graph. So you can have any number of graphs regarding this effect, or it's possible for us to create more and more graph. Each line can be drawn to a graph. But in NCERT text we are dealing with 4 main graphs. So the 4 numbers, number 1, number 2, number 3, number 4. So we are just discussing only that 4 particular graph. So let us see each one. Number 1, we have 3 parameters. For sure we have 3 parameters. Number 1, frequency. Number 2, intensity. Third one, in that video we have discussed this word emitter plate, and the other one is collector plate. So emitter plate means that plate which is emitting electrons. Collector plate means which is collecting electrons. So the potential of the collector can be varied with the help of a potential divider and a commutator. So that was the initial experimental setup. So with that you can vary collector potential. So the 3 variables are once again frequency, intensity and collector plate potential. So maybe we will keep either any one of them constant or 2 of them constant, then vary the remaining. So let us see. First time we are going to keep nu means frequency and accelerating potential. Accelerating potential means the potential given to the anode or collector plate. So that is a potential, you keep it as a constant. With these 2 kept constant, what we are going to do is you increase the intensity. Increase the intensity means the brightness of the light. For an example, just think about rains. Very little rain means not heavy rain, just you will say like sprinkling of water like that. Then that rain is going on, a huge shower is happening. So similarly, the intensity is going on increasing. At the time, small pebbles, then big stone, boulders, etc. can remove from the surface of the ground. Similarly, as you go on increasing intensity, the photoelectric current goes on increasing. So that is the first information. So I proportional to I. I in the sense intensity, the other I photoelectric current. So how comes as we increase the intensity, what happens? The ejected photoelectrons from the metal surface comes up. Once the ejected photoelectrons increases, photoelectric current goes up. So that is very clear, I proportional to I. That's all with the first graph. Now going to the second one. Here we are keeping frequency as a constant. Here we are keeping frequency as a constant. And now from this figure, 2 main inferences are there. Number 1, the same thing is over there, that also is there. Along with that you have 2 more informations. Number 1, if you start collector plate potential from 0 to a positive value, keeping frequency constant, you are increasing this collector plate potential positively. You can see that current goes on increasing. This is the way it increases. The photoelectrons ejected goes on increasing. Finally, it comes to a saturation value. So this is the intensity I1. I1, you know, intensity is proportional to current. So this creates a particular current here, known as saturation current. Again, another intensity I2. It again goes on increasing to another current I2. So for that particular intensity I2, this is the saturation current. Again for the new value, this is the current. So what we have studied is intensity is proportional to current. So when you increase the intensity, you are increasing the photoelectric current also. But for each intensity, you have a particular saturation. This is saturation current, this again. All the 3 are saturation currents for 3 intensities. So for a specific intensity, specific saturation current. And also for a particular intensity, you can see as intensity increases, saturation current also increases. So that's a very important information. That is, saturation current is directly proportional to intensity. Clear? And now from 0, reduce the potential. That plate A, you reduce the potential. And as it comes down and down, you can see that all the saturation currents is lowering, all the photoelectric currents is lowering and lowering, and for a particular point known as minus V0. Why minus? Negative x-axis, so it is minus. Minus V0, known as retarding potential or stopping potential, the photoelectric current becomes 0, no current. Means not even a single electron is able to reach at the point A. However forcefully it is coming from the emitter, it won't be able to reach A because that much reverse potential A is getting or giving supplied, or it is supplying such a negative voltage that no one from emitter could reach A. So that this photoelectric current becomes perfectly 0. So that is again another information. Stopping potential is independent of intensity. You know, when intensity is coming up, photoelectric current is coming up, right? But whatever be the number of electrons coming, intensity means what? The number or the brightness of the electron, photon. Even if so many photons are incident here, proportionate to that photon, you have the electrons ejected. Whatever electrons is coming over there, they all are pushed back so that none can reach A. That means independent of intensity. Stopping potential doesn't think about intensity of the intensity of the incoming photon. Nothing to do. So it is independent. That is why for intensity I1, intensity I2, intensity I3, all the three have the same potential minus V0. So that is an inference from the second graph. Third one, look at the third one. In third one, what you can see is, look here, for a particular saturation current, you have a particular intensity. So here we have kept intensity to a constant. When you keep intensity to a constant, you can have only particular saturation current. So for a given intensity, given saturation current. So this is the intensity, so this is the saturation current. Okay. Now, what happens? We are having different frequencies. nu1, nu2, nu3. When the frequencies are different, what will happen? Just think about, we have discussed earlier, when the frequency is different, for a metal, there is particular threshold frequency. So, if three different frequencies are there, what will happen? Three different frequencies can emit three different number of electrons. The electrons ejected becomes different. When the photoelectron number comes different, what will happen? They advance and go to the plate A. At the time, what we need? We need stop them. We need retarding potential to stop them. So, when the frequencies are different, what will happen? The energy, the kinetic energy is proportional to frequency, that you know. So, kinetic energy is different. When kinetic energy is different, stopping potential is obviously different. Why? Kinetic energy is equal to EB0. So, what is the way you come there? When you have different frequencies, we have different number of electrons getting ejected and the velocities also differ. Velocities differ means what? Kinetic energy differ. If kinetic energy differ, automatically EB0 also differ. So for different frequencies, the potentials are different. What is here? For different intensities, stopping potential is the same. For different frequencies, stopping potential is different. Same saturation current for different frequencies. Why? You are taking only a intensity. For a single intensity, the saturation current is single one. So these are the two main informations what you get from this graph. And finally the last one, fourth one. This is between stopping potential and frequency of the incident light. I told you only emission happens once it covers threshold frequency. So for metal A, nu 0 A. For metal B, nu 0 B. Nu 0 is threshold frequency. Once that is crossed, ejection starts. So this much threshold frequency is enough for A. But B needs this much threshold frequency. So a little bit higher. So for metal B, ejection happens only after exceeding nu 0 B. For metal A, it starts after nu 0 A. Once it starts, what happens? Frequency increases, what happens? Kinetic energy of the moving electrons increases. Kinetic energy increases means what? Stopping potential increases. More the energy coming, more the energy to push back. So kinetic energy is equivalent to stopping potential. E times V0. So what is the inference? As frequency goes on increasing, stopping potential also goes on increasing. So it is a linear relationship. So this is stopping potential, this is frequency. So after threshold, you can see whatever be the metals, it shows a linear relationship or a proportionality like this. This is proportional, I proportional I. Similarly, negative V proportional mu. Clear?